Hi everyone, welcome to this labs of data fabrics. In this lab, we are going through implementing Medallion architecture in Microsoft Fabric. So, Medallion architecture is a data design pattern that organizes data into three layers: bronze, silver, and gold. Think of it as a progressive refinement. Raw data becomes curated analytics ready data through structured transformation stages. Why three layers? Separation of concerns and reusability. Bronze preserves raw data. Silver provided a clean foundation that multiple gold layers can reference. Marketing might build a customer goal table, while finance builds a revenue goal table. So both form the same silver data. So let's try to understand the each layer. Think bronze layer is your landing zone. It stores raw data exactly as ingested from source system. No transformation, no cleaning, no schema enforcement. Like CSV files, JSON documents, log files, everything lands on like in bronze section. This immutability is important. You always have the original data to reprocess if needed. Now, silver layer is where transformation begins. You read from bronze, apply schema, clean nulls, remove duplicates, standardized formats, and write these to delta tables. Silver data is validated and confirmed, but this is not yet aggregated or modeled. Think silver as a single source of truth that it's cleaned but still detailed. Now it's coming gold layer. So gold layer is a business ready. You create star schema with fact and dimension tables, aggregate metrics, apply business logics, and optimize for specific analytics task or use cases. So gold tables power dashboards, reports, and machine learning models. They are fast, they are structured and purpose built. So in this lab, we will build all three layers using Spark notebooks. For bronze, we'll simply upload CSV files to a files folder. No transformation needed. This is our raw data archive. Now for silver, we'll create a notebook that actually reads those CSVs, defines a schema with proper data type, will like that adds auditing columns like timestamp and flags, and writes to a delta table using merge operations. Merge is key. That handles both new records and updates to existing records, making uh, like our pipeline idempotent. For gold, we'll create dimension tables. In our case, we are going to create customers, products, desks using slowly changing dimension patterns. We'll generate surrogate keys with monotonically increasing IDs. So we'll go through that one. Then splitting columns like there is a name, we'll divide into first name and last name. And when you're talking about increasing ID, like if we add item one after another, so it will sequentially increase the ID number like 1, 2, 3, 4. There are 101, 102, 103. Then we'll build a fact table that joins dimensions and stores metrics like quantity and revenue. So the result is a complete star schema optimized for analytics. Dimension provides context, fact provides metrics, and relationship enable rich multidimensional queries. We'll use PySpark throughout, leveraging data frame operations, Windows functions, and Delta Lake merge capabilities. The code is modular. Each layer is a separate notebook, making it easy to debug, test, and reuse. And then finally, we'll create a semantic model from our goal tables, defining relationships and measures for Power BI reporting. The semantic model becomes the interface between our data engineering work and business analytics. So the Medallion pattern is not just for Fabric, it's a best practice across data platforms. But Fabric makes it seamless with integrated lakehouse, notebook, and semantic models, all in like one workspace. So by end of this lab, we'll have built a complete Medallion architecture from raw files to star schema ready to enterprise reporting and analytics. Let's architect our lakehouse the right way with Medallion design. We'll go through create a Medallion architecture in Microsoft Fabric Lakehouse. In this exercise, we'll build out a Medallion architecture in a Fabric Lakehouse using notebooks. We'll create a workspace, create a lakehouse, upload data to the bronze layer, transform the data and load it into the silver delta table, then transform the data further and load it to the gold delta tables, and then explore the semantic model and create that relationship. So let's connect to the Microsoft Fabric homepage. So let's start the lab. Very first thing, we are going to create a workspace. Click on workspace, create a new workspace, give a name, and then under advanced, make sure that fabric capacity is enabled. Click on apply. Now we are going to create a lake house. So click in new item under workspace, search for lake house, click the lake house, give a name. Lake house names you are going to use as per lab is cells. Question is that one, click on create. So it have created in tables and files, which is empty right now. Now create a subfolder under files, and we are going to give that name is bronze. Click create, and now under bronze we are going to upload those data. So upload files, these three files, click open, load. So you can this three files has been uploaded there. Three files have been uploaded there. So now we are going to transform data and load into silver delta table from the so for that let's go back into workspace, create a notebook, give a notebook name transform data for silver, and then click create. Now if we go back to Lakehouse, now here you see open notebook, select existing notebook, transform for silver, click open. So you can see there is just simple commands and this notebook. So let's add a code here. So notebook enables you to run code in variety of language. So let's execute the cell. So here we are creating a first a schema. The schema has got all those columns names, and then import all files from all files from branch folder of Lakehouse, and then displaying the top 10 files. So you can see that values here also. So the code, like the code we ran, loaded the data from CSV files in the branch folder. I'll click code. Now we are going to add columns for data validation and cleanup, and we are using the PySpark. So if you look here, we are going to use PySpark data frame to add a columns and then update the value based on if customer is null or empty. So let's execute this one. So session is ready. Now we are going to modify this table. So for the sales silver table in the sales database. Define this schema for the sales silver table. So let's execute that one. So it's running. So that has been successful. Now we refresh that one, table section. So we can see that sales silver table is listed here, and that triangle is a delta table. Now we'll do a upsert operation, which is update and insert. So if you look here, so first we'll update existing records, and then when update is done, here you see that this is update, this part, df updates, and then based on condition, it's going to insert the values, like if value means then update like this part, and then it's insert. So therefore this is upsert. So now to execute this one, you just execute this run cell command. So you can see that session is ready and 11 of 11 succeeded. So this notebook use the compute resource. To stop that compute resource, we can just you see that options, stop that session. So session is stopped successfully. Now we'll explore data in the silver layer using the SQL endpoint. For that, let's go to workspace. This is the SQL endpoint. But other option, you can go, like if I go back to workspace, why that option I cannot see here, that SQL Analytics endpoint. So you can select that one, and you can also see the type underneath. So select that one. So it's going to SQL Analytic workspace there. So now here you see that new SQL query, and so just select that new SQL query. Now if you down below, there is a two options. One is visual query, one is SQL query. So select that SQL query, and copy the code here. Execute that command. So here we see that query actually calculate the total sales for each year from that sales silver table. Now let's go for another tab, and this time we are just you see sum of quantity. So we are just calculating the total quantity of items purchased for each customer, and we are calculating the top 10. So click run. So you can get the value here. Now so we have successfully taken data from the bronze layer, then we transformed it and loaded into silver delta table. Now we are going to use a new notebook to transform data further, like model it into a star schema and then load it into gold delta tables. So for that, let's go back to workspace and create a new notebook. Give transform data for gold name, and then click create. Now select add data items and existing data source. We are going to select the sales Lakehouse. Click connect. Now if we expand that one, should see that sales silver table listed under table section of this for this notebook, new notebook, under that uh, workspace, if you see, and lake. Now this initial comment section you can just remove, and otherwise you can just add or modify, like you can just delete code block, we can create a new code block, or we can set up markdown. So now let's to load the data um, uh, to data frame. We are just load data from data frame as a string point. So we are just using data frame and read double cells and cell silver. So execute that command. Now we are going to create a date dimension table. Execute that one. So that has been completed. Now we will add and run the following code. So create a data frame for dimension date gold that we created earlier, and then display the first 10 rows of the data frame to preview. So run cell. So we can preview the data here. So next code block, what we are doing, we are just updating the date dimension code, or like date dimension when we are actually inserting. So when we are getting a new data, just updating this double. If I said that we are updating that one, so let's execute that one. So now we have completed date dimension is now set up, and we are going to create a customer dimension now. Execute that one. So we are manipulating data here. ETL jobs that you will do based on your requirements. So here is that we are focusing on now that dimension delta table for customer goal. Now, if you look here, we are just setting up a code to drop duplicate customer name, and also like you get the value. For this part, actually, you need some SQL knowledge that but here we know we're using PySpark, so it is better if you know how actually working, then it will be easier to understand. So if you look here, that drop duplicates, and if you see based on this condition which you select ultimately from your table, just to make sure that that's there. And also second part is that it's splitting customer name to create first name and last name separately, and after that it displaying the 10 rows. So that is that we are doing many operations here. So now here we are going to uh, create the ID column for customers. And if you see here, so there is a join operations that we are running. And they are using left empty, join to exclude duplicates that's already existing, like into this customer goal table. And if you look, let me see what other things going on. This is and it's also increasing use that uh, monotonically increasing. So this one ultimately generate unique customer ID. You see it's ongoing, it will update +1. And display, it will give us like display for 10 head top 10. So execute that command. Now with this we are just making sure that whenever any data is coming, it remains up to date. So it's update based on insert. When some insert is happening, it will update. So data will be up to date. Execute the cell. So now we have done with the customer. Now we'll do the similar, like repeat all those steps for the product dimensions. So create a product silver data frame and first on 10 rows. Now we are going to create an IDs for the dim product goal table. So let's execute that one. And similar, like where we'd like to make sure that product the table remains up to date when we are inserting some data. It just need to be up to date. So now we are going to create the fact table. So here we are creating a new data frame to combine sales data with customer and product information. So if you look here, we are just combining all of them. So joining method df1, df2, df3. So customer is df2. You can go through all those logic. Now we have to use like upsert statements, like if there is any new insert, it's make that up to date. So here we are just using delta lake merge operations to synchronize and update the fact sales goal table with new sales data that is in data fact sales code. So we have a curated model goal layer that can be used for reporting and analysis. Let's create a semantic model for this one. For that, we need to go to our workspace and Lakehouse. Let's go to state Lakehouse here. And you see that there's option for new semantic model. Select that new semantic model ribbon. It's fetching the schema. So give a name for this one. Workspace is in this one. Select the table we created. So you can select dim date gold, dim customer gold, dim product gold, and fact sheet gold, and click on confirm. That's in progress, so we can monitor the status. So if you click on monitor, you can see the transform data for silver is succeeded. You can see the view details or historic terms, and now it's going from all those ETL tools. It's going from data for gold. That is one thing. And now if we go to workspace and the semantic model we created, select that semantic model, and there are few options here. We can explore open semantic model. So you can see that semantic model is there. Let me close these two. So from here, you or other team member can create report and dashboard based on the data in your lakehouse. So these reports will be connected directly to the goal layer of your lakehouse. So they will always reflect the latest data that we have done in our lab. So that's all for this lab. See you in next lab. Thank you.